Okay, for 5.3 homework, there was a 2-column proof at the bottom. This one, we're using the diagram to the right, and we are told that triangle ABC is congruent to triangle CDA, and that is our given information. They want us to prove that ABCD is a parallelogram. So what we want to do for that is, if we go back to our notes from day 1, we can use any of these to prove that we have a parallelogram. So we can show that both pairs of opposite sides are congruent. We could show both pairs of opposite angles are congruent. We could show both pairs of opposite sides are parallel, or consecutive angles are supplementary, and diagonals bisect each other. So we have all of this that we can use to prove that the triangles are or form a parallelogram. Okay, so the easiest way to do this is to prove that the opposite sides are going to be congruent to each other, especially because they gave us congruent triangles. And if you remember back to our congruent triangle chapter, we know that the corresponding parts of the congruent triangles are congruent. So we know that AB, because those are the first 2 letters, are going to be congruent to CD. And if you remember, you can put CPCTC, or you can put definition of congruent triangles. Whichever one you remember or works for you, you can put for your reason. And using that same line, we know that BC, the last 2 letters, are going to be congruent to DA. So we can just add that on to the same line. Now we have both pairs of opposite sides are congruent. That's enough to say we have a parallelogram. So we can go on to our next step, and we can say A, B, C, D is a, and you can use the shape for a parallelogram. You don't have to write out that whole word. And for our reason, we're going to put both pairs of opposite sides congruent implies that we have a parallelogram. And that is our answer. There are a few different ways to prove this as a parallelogram, but this is the fastest and easiest way for this example. So instead of trying to make it complicated and going over the other ways, I'm just going to show you this one for now.